For all of our attendees on the webinar today, please don't worry. Your cameras will be off, so you will not be on camera. So for your privacy, you can be rest assured that you are not going to show up on the recording, but we will be sending out a copy of the recording to everyone who registered after this webinar. So real quick, before I hand it over to our robotics faculty, my name is Marissa. I work in the College of Engineering in the graduate admissions team. And I will be just going over quickly a little bit about Northeastern, and a little bit about my role is that I work with prospective students, much like yourself, who are exploring their programs of interest. So if you have any questions, either for myself or the faculty, please feel free to drop them in the Q&A as we're going through the presentation. My colleague Hirsch Mehta is also here as well, and he's very happy to help you if you have questions as well. So just to start off, Northeastern is a top-ranked Research One and experiential learning university. Our co-op program, which I'll talk about later in the presentation, is ranked #1 in the country, and we're also ranked #1 for co-ops and internships. Overall, COE is one of 10 colleges and schools in the college or in the university, and overall the university has 10,000 or 50,000 students. We offer degrees anywhere from the BS to the doctorate, and our university has offered $282 million in external research awards. And although we are going to be talking about the Boston campus today, we do have 13 campuses across the network. So here is just a snapshot of where all of our campuses are located. You can see that we are in the United States. We are also in Canada, and what's not listed on that page is we also have an undergraduate campus located in London in the UK, but these are primarily where the College of Engineering is, and you can see that it's a very wide network. So for COE, we do have a fairly strong mission, so you can see that on the page here. And as you can see, our dean often says that good engineers solve problems, great engineers solve important problems, and transformative engineers discover and solve important problems. So really our goal here in the College of Engineering is to make sure that we produce transformative engineers, be that at the student level or the faculty level. On this screen, you can see just what our 6 departments are in the College of Engineering. You can see that there are a range from the disciplinary to the interdisciplinary. I put this here on the screen today just so you get a sense of the diversity of programs that we have in the college and who your other student colleagues might be. This will sort of lay it out a little bit better for you. If you remember from the first slide, our entire student body at Northeastern is 50,000 students, but you can see that our College of Engineering makes up about 1/5 of that total population. We are unique in that our graduate students almost far outnumber our undergraduate students. So if you are a grad student in COE, you are among many different students. And our MS enrollment is actually up 58% from 2019. So as I mentioned, we have PhD, MS, and BS degrees. We also have graduate certificates. And together we have about 110 different degrees in the college itself. We also have quite a few faculty. We have about 403 full-time faculty, 245 of those are tenure or tenure track. And as you can see, we are also very good at earning external research awards. The college itself earns about $118 million. So just to see where our programs are sort of spread, we do have 9 PhD programs and 32 MS programs at the graduate level. For the MS degrees, I wouldn't get too used to that number. They're constantly changing as the industry evolves. But here you can see where our degrees are located, what campuses offer which degrees. So if you are interested in a degree other than robotics and you're looking to see a different location, this is just a really good snapshot of where those other programs are. So with that, I will hand it over to our faculty and they can tell you more about the program.
Rifat, do you want to go?
No, why don't you take the lead and I'll jump in once here and there.
Okay, all right, great. Welcome everyone to this introduction to the MS Robotics program. One of the really cool things about this program is it's highly interdisciplinary. We have 3 departments and spread across 2 colleges. We admit students in concentrations in computer science, in electrical and computer engineering, and in mechanical and industrial engineering. But what we do is, as you'll see later, is We have some core courses in each department that you need to take. But then the electives are spread all over the field of robotics, and you have a very wide variety of subjects you can choose from. And then the other, two parts that I love to highlight about our program is, one is that we really try and push the limits in terms of the sensors, and you'll see this again, the sensors and the platforms that you're going to work with. So, we have an autonomous car. So do 10 other universities. But we're the only university that allows the MS students to actually go out, use it, and do classwork on it. So next slide, please. So here are some of our robots. I already mentioned the autonomous car. We have a Spot quadruped, and this is a very small fraction of the whole robots. And I have to apologize. These are almost all the ones that are just based in electrical engineering. But we have autonomous cars, we have quadrupeds, and we're getting more. We have underwater vehicles, we have underwater surface vehicles, we have drones or unmanned aerial systems. And then next slide, please. And then, what we really do is look at what are the applications of all these systems, and they come across from a variety of things. So you can see, there in the middle is a video of a manipulator working, doing some work that was associated with the seafood industry. On the bottom, we have a humanoid that we used to have here, and we're getting another one. And the concept there is that of a cobot, how a humanoid could work with people. And this is, a very active area of research in industry as well. And then we have what we call field robotics. And all this is embedded in this matrix where we want to talk about things like embodied AI, systems design, control, and the ethics of doing things, security, and of course, how do we make sure that humans and robots team in a way that is effective? Next slide, please. And I think there's a movie right there on the left if you want to play that. And and what we're going to do here is just if it doesn't play, that's all right. Is just give you highlight some of the research that's going on. It's just a snapshot. We have if I look at the Institute for Robotics, we have 40 members in there, and each one of them is doing amazing work. Again, this is more specific to work that that I was doing here. We were looking at understanding what's happening to penguin in Antarctica, and good news with climate change. For once in my life, we found a super colony of 1.5 million penguins, which made news all over the place. And what I want to highlight is, if you look at the picture on the right, there's a student there launching an unmanned aerial system, and that student was one of our students. He got to go out to Antarctica. He did all this work. He went on to to a career actually at Waymo. He just left Waymo recently. He was laid off and has another job. And so, what I want to emphasize with this is that we're working on real systems, on really hard problems, and then by working on these problems, it enables our students to enter industry with a huge advantage over other students who might not have had this kind of exposure. Next slide, please. And here's another example. I think the top is a movie again, Marissa. I don't know if it plays. Yeah. And here, this is a work done by one of our PhD students. And what she's doing is she has essentially an invisibility cloak. She's looking at multiple cameras and how we might use them, and and how we might be able to segment out people and actually reconstruct what's happening in the background. And these things are, for instance, very important when we're looking at autonomous cars. What happens? Can you see through stuff to see other things that are important? And so again, we are really trying to push the limits on theory, on algorithms, and on applications that matter in the real world for industry, for all of us in society. Next slide. Rifat, I'm going to let you go with this.
Sure. As Hannah mentioned, the spectrum of experimental setups and both in research and education are pretty very broad. And here are a couple of examples from mechanical and industrial engineering. We have colleagues working on effective computing, human-machine systems, human-in-the-loop systems, and is an example of how one of our faculty integrates driving simulators with human subjects and aims to understand the human physiology as they are performing driving tasks. Next slide, please. Another area of research that is very deeply integrated in the Institute of Experiential Robotics is the work of Professor Whitney, who heavily works on soft robotics, medical robotics, and teleoperated robotic systems. Here, he's actually showing, I don't know if the video runs, but is an example of the larger one with a little kid, that's his daughter. And he's actually demonstrating that he can build safe robots that could interface and interact with young kids. And how do you control that? And how do you design these robotic systems from materials, actuators, and controls? Next one. Another example that we have been actually growing is rehabilitation-based robotics. And we actually have a very strong physical therapy department. And we are fortunate to be in the land of the best medical research centers in the country, in Boston. And so we have colleagues actually investigating a variety of different robotic assistive rehabilitation devices that encompass design, electromechanical design, control, artificial intelligence, and obviously a patient testing. Next one, please. Along those lines, we also have faculty again building lower limb exoskeletons to assist amputees to comfortably walk, and they're working on and some different aspects of these designs, including customization for patients and so these are some areas that are where we have research, but most of these faculty that we are showing you also teach in these areas from fundamentals to some specialized topics. Next one, please. Along those lines, the university led by Institute of Experiential Robotics, Professor Whitney and Professor Taskin Padir, and have won a major Avatar X Prize. This was a worldwide competition, and I believe Northeastern came the third. This was a state-of-the-art teleoperation device where two robots would be controlled, one of them by a human and from remotely in a location where the other robot is, to interact with the real world. So if you just Google Avatar X Prize, you'll find more information on that. Next one, please. Actually, this is just shows a few of the developments of the X Prize system, where you would imagine that an individual moves a robot attached to their forearm, and then the remote site there's a copy of the robot that does some type of a task. Next one. Next one. And overall, as Anu said, robotics at Northeastern is truly interdisciplinary, and this is what students say. I talk with them, and I ask them what they find really attractive. In our program, it's truly interdisciplinary. There are no physical boundaries. Whether you're a computer science student, electrical and computer engineering student, or mechanical and industrial engineering student, it doesn't matter. You have access to courses offered by all these disciplines, because we really believe that you should become a well-rounded robotics person, and with all the perspectives you can gain from these courses. Next one, please. I won't get into too much details maybe here, but overall students follow 3 different tracks. They can follow either one of these tracks, and regardless, they will complete 32 credits, and where each course is 4 credit hours. So that corresponds to about 8 courses. And just the way that the completion is done is slightly different, and because some students can do a thesis, which means they will take 2 less courses, but they will do a thesis. Some can do a project, which means they take 7 courses plus a project course, and they can also decide to pursue a coursework only option where they would be completing 8 courses each 4 semester hours. In the thesis and project option, students find a faculty advisor and on campus who will work with them, potentially in a lab setting and depending on the nature of the research. And students gain lab level experience, which could be potentially useful for their careers, whether they want to go PhD, they want to go into industry. There are some additional options there for students to explore. Next one, please. Very quickly, maybe a sample core curriculum, how it works. Students, whichever department they are in, they take one course from each of the categories, one from mechanical, one from electrical, and then one from computer science. That's 3 courses. And then depending on which home department you're coming from, you take an additional course from that department from one of these courses that listed here. That makes 4 courses. Next slide. And then you can complete the remaining 4 courses from a large spectrum of electives. And this is just a partial list, and the list is growing. And again, it doesn't matter which department you're in. If you want to specialize in electrical engineering, maybe you're a computer science student, that's totally fine. You can take 4 of your electives in electrical engineering if you preferred. Next one, please. Maybe I'm going to stop here. This is actually Hanu's course, so he's definitely going to do a better job than me explaining what's happening in this course.
It's your course too, really. No, just kidding. You know, we just thought we'd put up one example class, and this is, you know, we like to call this boot camp for robotics and electrical engineering. And what we do here, as you can see from the introduction, is we make sure everybody comes up to speed. You know, if you're a CS major, we make sure you understand some electrical engineering and putting systems together. If you're a ECE, we make sure you're programming. And if you're a mechanical engineer, we make sure you do, you know, some nice programming, come up to speed with OpenCV and ROS, which are the classic packages. And then also get the ECEs and the CS people to understand that mechanical engineering is also extremely hard and fun and interesting. You know, this class has no exams. It's just lab-based. We have, I believe we have 5 labs and 2 projects. Some of the projects are individual, some of them are working in teams. And again, what's really important is the sensors and platforms we work with are very state of the art. Okay, they're, you know, one interesting story, we use these very high-end inertial measurement units from this company called VectorNav. And VectorNav likes us so much, they've hired 4 or 5 of our students. And because they said, you know, they get a really good introduction to some of those issues. Again, you know, the emphasis is on building and using systems like you would see in industry. You know, one more story while we're at it. A few years ago, one of my students came up to me and said, "Hey, professor, I got a co-op with Mercedes." And I'm like, okay, great. And he says, you don't know what happened. I showed them that I had done this mapping with LiDAR with an autonomous car. And they, you know, during my interview, and they said to me, where did you get this data? And he said, oh, I collected this data. And he said, they didn't believe me. They said, what do you mean you collected it? You got it from the web. And he said, nope. And he showed them the slides that were put together by him and his other team members. And he says, that's what got me the job. And so I think, you know, that's the whole philosophy. That's why we're doing so well right now, is we really want you to succeed, and we're going to give you the tools, the packages, so that you can do that. Next slide, please. Rifat, do you want me to continue, or do you want to take over?
Please continue.
Okay, and then one other thing, which is, you know, kind of new, we just moved into a brand new building. What is it now, 9 months ago? Most of the robotics people were, of course, spread across the campus, but there's one thing which is independent of the robotics, is the Northeastern Makerspace. And, you know, it is this amazing facility where anybody with a Northeastern email ID, any student, any faculty, any member of the staff can go there. They, you know, they do an orientation, and if you are not familiar with something, they'll train you up with it. But then you have free access to pretty much anything you can think of. Everything from milling machines to woodworking to 3D printers to laser cutters to sewing machines and tools. And it's an absolutely amazing facility, and it's open to everybody on campus. And it's, you know, what's really nice about it is it's busy, but there's always room for people to do what they want to do. And it's, like I said, I wish we had these when I was going to school as an undergrad or a graduate student. This is really, truly amazing. Next slide, please. All right. Marissa, do you want us to do the co-op overview, or how do you want to go?
Yeah, if you want to do the co-op overview, that's totally fine. I'm also happy to present on it, but
Why don't you go ahead?
okay, perfect. Great. So just as a little overview, so our co-op program is a really very unique to Northeastern. There are many universities in the United States that do have co-op, but ours is 115 years old. So our university is celebrating that this year. And just as a fun fact, for those of you that don't know, our co-op program actually started with 4 engineering students. So the co-op program has been alive in the College of Engineering for over 115 years. So this is a program that has a good history and it's not new or anything like that. So if you are interested in co-op, it does have the background and the history. So it is something worth looking into. I do like to throw out, just before I talk about co-op, that co-op is not required of students, but it is highly encouraged. And we do have many students, over half of our students will take up the co-op option. So our co-op is the opportunity for students to gain real world experience as part of their academic curriculum. So unlike an internship where you're maybe working for a company, you're not really, you're more in a support role. The co-op is actually a program where you're working in industry in the company as a real professional position. So you are working as an engineer in your co-op. To date, you can see some of the numbers here on the screen. For the academic year 2024, the college itself had over 3,000 students go on co-op, and we have over 2,000 co-op partner employers. So those are just a small sample of them on the screen there. Those are some of the companies that you may be familiar with, but there are also a number of different companies that are not on the screen. We've had students go on for to work at Fortune 500 companies, small startups, nonprofits. I would really encourage you, if you are interested in co-op, when you are ready to start co-op searching, that you look at a number of different companies, a wide variety, because you're going to have a little bit of a different experience depending on what kind of company you're working in. And you're not restricted to just doing your co-op in Boston. We have students who do co-op in over 23 countries and over 40 states. So you are welcome to look in a number of different areas. You don't have to restrict your search just to Boston or even your home, wherever that may be. And then you can see here too on the screen that, again, not required, but many of our students who do go on co-op will actually receive a job offer from the company where they've completed their co-op. So co-op is a great experience, not only in terms of getting to understand what you like and don't like about industry, but it's also a great opportunity to build up your network. So these are just some of the characteristics of what defines a co-op. So your job function will align with your major. And for this reason, you are not allowed to go on co-op either your first or second semester or your last semester, because we want you to be able to apply what you've learned in the co-op in your classroom to your co-op. And likewise, once you return from co-op, we would like you to be able to apply what you learned from co-op to the classroom when you finalize your degree. So most of our co-ops are full-time. This is either working 35 to 40 hours per week, depending on what is constituted as full-time in terms of your company. We also have different lengths of co-op that you're eligible to look for. We have 4, 6, or 8-month co-ops. The industry is flexible. These are also paid experiences. So depending on what type of company and what kind of position you're in, your wages will vary, but these are all paid positions. For those of you who are international, this is your curricular practical training. So this is something you are eligible for. And these are recorded on your transcript as a non-credit class, but you are a full-time student while you are completing your co-op. So we have many benefits of co-op. These are just a small list. There are many more, but you are advancing your skill set and exploring your interests. And you're learning from folks firsthand in your chosen field. You're working with them day to day. You're learning what you like and what you don't like. You're also developing your valuable job search and interviewing skills. Prior to going on co-op, you'll be taking a co-op course with a co-op advisor. This is somebody who will kind of teach you how to be a professional in the field. These are things like you'll be learning things like soft skills, like interviewing, networking, and just how to be a professional in the field. And this person is really important for you as someone you can reach out to while you're on co-op, and they'll support you along your co-op journey. You'll also be growing personally and professionally while building your network. So as I mentioned, many students are offered a job at the place where they do their co-op. It's not that you're required to take a position in that company, but it is a place where you are building your network for someone you can use as a reference or a letter of recommendation if you go on to do a PhD, for instance. So even if you don't plan on working in the company where you do your co-op, I would still strongly encourage you to take advantage of building that network. And as I mentioned, you're also getting paid for these positions. Our average salary range is $18 to $41 per hour. Again, that will depend on what type of position you're offered and what kind of company you're working for. And if you're international, you can utilize your CPT. So next, I'll just talk about our graduate ambassador team. Unfortunately, one of our team members is not able to join us today, but I would encourage you to look at our ambassador website. It'll explain more who they are. They are a group of current students. They are mostly at the MS level, although we do have some PhD ambassadors. And I would encourage you to reach out to them on their various networks. They are a great resource for you because they can talk to you what it's like to actually be a student at Northeastern. I know from the admissions standpoint that I can answer some of your questions about the application, curriculum, but I can't actually be on the ground with you telling you what it's like to sit in a classroom or to do your homework, or to kind of look for resources on how to succeed in class. These are what our student ambassadors can do. They do respond to student inquiries on our COE admissions page. They have a form you can fill out to connect with them, or you can also email them. They're really happy to answer you. But I would, before you reach out to them, just as a caveat, they are current students, so they are doing things like research and coursework. So if they don't get back to you right away, please rest assured that they will. They're just very, very busy because they're current students. Next, I would just want to throw out some things that you can do to get involved as a student at Northeastern. We have a number of engineering student clubs that you would be more than welcome to join. You don't have to join robotics specific clubs. You can branch out and join other professional societies or different clubs. These are a great way to meet some of the students who are not in your program. It's really, really easy to just not to get stuck in your program, but to just be with the students in your program all the time. So we do encourage students to get involved, just to network with other students. And then clubs are a really great way to test out what other specialty areas you might be interested in. You might be interested, in our student government, for instance. That's a lot of our students from COE will be interested in joining that. And it's a great way for you to get involved and to meet other students. While you're at the university, you'll also have a lot of support for your career success. We do want you to succeed while you're in the program, but we do know that ultimately your end goal is to graduate and to be successful upon graduation. So some of the folks that are able to help you with your career success would be your co-op coordinators. So they would teach your co-op class. They also offer workshops, including global co-ops. They also speak for international students. They teach you how to self-develop your skills. They'll mock interview you, help you with your resume, etc. They also provide one-on-one career advising, and they also are the ones out in the field developing the partner relationships with our co-op partners. You can also feel free, if you're an international student, to speak to our Office of Global Support for CPT advising, or our Global Student Success Office for international students. They'll offer tutors, workshops, and webinars just to help you be more engaged and to be successful. In the College of Engineering, you also have the advantage of taking a relationship with the student services. This is a professional advisor. So unlike a faculty advisor, this person works with you specifically for support in your program. So they can't tell you, they can't advise you what classes to take, but they can help you with your career planning, your course planning, your course audit, and then they can help you with registration. And if for whatever reason you end up on academic probation, they can help you with resources to get you back into a successful place in your program. You're also welcome to take advantage of our Career Design and Employer Engagement Office. This office will offer things like career fairs, workshops, and career advising appointments. They can also read your resume and mock interview you as well. And this office is actually available to you after you graduate. So alumni are also more than welcome to take advantage of this office. So for next steps, if there are any of you on the call today who have already been accepted, I just want to extend a warm congratulations to you. This will be your roadmap for enrolling in your program. So the first thing, of course, that you'll get is your admissions letter. And after you're accepted, you'll get a series of emails welcoming you to the program, some of those being from your graduate student ambassadors and our faculty in the program. Before you can move further in the process, you will have to pay your enrollment fee. That's a $100 deposit that goes towards your tuition, and it is required of all students. But once you do that, you'll be able to activate your student account and apply for your I-20. And in parallel, I would suggest doing some things to ensure that your transition to your program is smooth, like starting your your university and counseling health report, as well as looking for housing and accommodation. And this is something I would encourage you to reach out to the ambassadors for if you're getting stuck in the housing process, because they've also moved here as well. Most of them are not from the United States, so they've also had to juggle both moving to a different country and moving to a new city at the same time. So if you do need advice, they obviously can't find your accommodation for you, but they can help you, sort of teaching you where to look. Closer to the semester, you'll also have to plan for orientation. Our student services team should be sending information on that shortly if you are arriving for spring. If you've been accepted for fall, that usually comes out in the July timeframe. And then once you're here, of course, you'll check in with OGS. You'll also receive information on course registration, and then that should ensure a smooth transition into your program. For those of you who have not yet been accepted, if you have not yet applied, we are accepting applications for fall 2025 at this time. Our spring application has mostly closed unless you are a domestic student, then you can apply until December 1. But for fall, you still have plenty of time to apply. Although we do have priority deadlines, you'll see that our final deadlines are not until June and August. So I would encourage you to submit your application as soon as possible, just so you receive your decision quicker, but please do know that you have plenty of time to submit your application. And our admissions requirements are on this page for attending our webinar today. If you have not yet started or submitted an application, you are welcome to submit an application with our application fee waiver code. There will be a question in the application asking you if you have this code. You will simply select yes to that question and insert the code. Unfortunately, if you've already submitted an application, we are not able to waive any application fees retroactively. But as for the rest of your requirements, you can see these are very similar to perhaps other universities that you may be applying to. We only require 2 letters of recommendation, unofficial transcripts, a statement of purpose, and a resume. And if you are an international student, you may feel free to submit an IELTS, TOEFL, or Duolingo exam for your English language proficiency. And currently for this academic school year, the GRE is not required, but if you are taking the GRE for other schools, you are more than welcome to submit a GRE score. And lastly, I would encourage you as you are going through the process just to keep in touch with us. You can always feel free to go on our graduate admissions website. We have FAQs on there. So if there is a question that you have, it has most likely been asked and answered. So please do feel free to look through those. You may, of course, if you can't find your question or if you prefer to speak with somebody, you may always reach out to our graduate admissions office or our graduate student ambassadors if it is something related to student life or being a student. You may also find our application on that page as well. So that is it for the presentation. So I know some of you do have questions in the Q&A, and I see Hirsch has been really good at answering some of those. But if you do have any additional questions, please do feel free to drop them in the Q&A, and we're happy to go over them. So I guess we do have one question in the chat, which I can pose to our faculty. So the student is asking if the department accepts students with a BS in cognate backgrounds. Would that be somebody who could apply to the program?
Rifat, do you want to answer that, or do you want me to take it? So what kind of background? Could you repeat that, Marissa, please?
Is it cognate background? COGNATE?
So, typically for robotics, we require you to have an engineering degree. It doesn't have to be in CS or mechanical or electrical engineering. You have a degree in biomedical engineering. We're going to have a new concentration for that. But, if you have an engineering degree, we will definitely consider you. If you don't have a hardcore engineering degree, unfortunately, the program is structured such that you would have a very hard time in it. So we don't consider applicants who don't have an engineering degree.
Perfect. Thank you.
One thing we have observed is that depending on their preparations, some students with a physics background do well in robotics. But what is really important as these students, whether they have an engineering background or physics background, they must have taken obviously a good number of undergraduate level physics, differential equations, math, calculus, a good number of programming languages, and then they need to have some more advanced level, either circuits, depending on their backgrounds, right, and electromagnetics, or if they're mechanical, dynamics, vibrations, and these are like important topics. Again, every major has different strengths, but we have seen physics students being successful in the program.
You're absolutely right. Thank you for pointing that out to Rifat. Yes.
Yeah, of course. I mean, you didn't exclude them anyway, so I thought I just didn't want to miss that. So yeah.
Right.
Great, thanks. So I do see a question. How many students have you already accepted in your PhD and master's, and how many more can get admission? So I unfortunately don't have exact numbers on that, but I can tell you that if you, or at least if you're applying for fall 2025, our deadlines have not even passed yet. So every single one of our programs is still accepting applications. So I would definitely encourage you to apply if you haven't done so already. Our application has been open for a while, but please do not let that discourage you. We are still more than happy to receive your application.
Yeah, and one thing I'd add to that, Marissa, is that we don't have a fixed number. It's not that we're going to take the top 50 or the top 100.
Yeah.
What we are going to do is evaluate every single application on its own merits. We have one of the robotics is one of the hardest programs to get into in the university. We do have very high standards, but if you meet those standards, we're not going to limit you from getting admission into the university.
Great, thank you. So we do have a question from a student. I applied for mechanical engineering. Could you please tell me when decisions will be released? So this is a great question, and I know a lot of you probably have these questions as well. So specifically, you're asking about PhD. PhD decisions have a very, very variable timeline because we have to match the student's academic background not only to a professor, but also there has to be a match with funding. So unfortunately for a PhD student, the timeline can vary widely. We've had students get their decisions within a couple of weeks, but also we've had students have to wait a couple of months. So the PhD decision process is quite complicated. So I do say that you can feel free to keep in touch with us as you're waiting for your decision. But if you haven't heard back in quite a while, I know it's very stressful, but please rest assured that that is very, very normal. At the MS level, decisions do tend to come out a little bit faster. Faculty have a lot of applications, so it can take a number of weeks just because in addition to reviewing applications, our faculty are also teaching, doing research and things like that. So, and everyone is reading your entire application. So it is quite a holistic review. So it can take a number of weeks to get a decision. So I would encourage everyone to be patient and just to monitor their application statuses, but just know that you can feel free during the process of waiting for your decision. You can reach out to admissions at any time and we're happy to answer any of your questions. So we have a question. What are the major subjects of focus for a CS student? I guess for the faculty, would you, is there anything you would recommend in terms of looking for classes for CS students or?
Marissa, I think Lawson is on there, but I think he's on the attendees, so maybe you could turn him off.
Oh my, I apologize for that. Yes. I will make it. I apologize for that, Lawson.
Sorry, no problem. Could you repeat the question, please?
Yes, what are the major subjects of focus for a CS student?
You mean on the admission side or after entering the program?
I believe after entering the program.
Well, so I think the overall, you know, the subjects are fairly similar in a certain way, or overall concentrations, meaning that like what you actually have to take in the core is actually like that's really the only difference. You know, as a student in CS could take basically all mechanical engineering electives if they want. But I think generally speaking, we would assume that CS concentration students would primarily gear their degree towards the CS side. The list of electives is online. They are heavily focused on robotics and robotics applications, but also tying in things like machine learning, artificial intelligence, and so on, right?
Thank you so much. And then I see we have one more question. Would having a mechanical engineering graduate degree with software experience be ideal for this course? Would you consider this type of profile? I believe so. That would be correct. Having a mechanical engineering background would definitely be very ideal for this program.
Yeah, we have a good number of, we have a lot of mechanical engineering students in the program, and some have prior software experience, and definitely more the better.
Great. So I do not see any additional questions in our Q&A. So I think we are good to end the call. Just before we close, I just want to say thank you to our faculty, Hanu, Rifat, and Lawson for joining today. And I also thank you to Hirsch Mehta, who's been answering some of the questions in the chat. So again, if you have any questions, please do feel free to reach out to Graduate Admissions. We are very happy to help you. And thank you so much, everyone, for joining today. And have a wonderful rest of your day wherever you are in the world. And thank you again to our faculty.
Thank you, everyone. Bye-bye.